Hello everyone, I am Dr. Pranit. I'll be teaching chemistry today. I'm excited to connect with you through Knowledge Temple, a platform dedicated to provide quality education and mentorship for the students across India. Here you'll get a structured learning, live lectures, mock tests, and performance-based rewards. Today we'll be starting off with the S block elements. As we know in the last lecture, we learned about the periodic properties and characteristics in a periodic table. Okay, so in the continuation of the previous chapter, the most convenient chapter to be learned and you have a go through to the previous things and apply the previous what we have learned in the previous lecture and nothing but the S block element. Okay, so S block, as we have know, since we have studied the periodic table, it consists of an S block element, which is the lowest upper, which is the upper leftmost part of the periodic table. As we have seen here in the mention, it is the hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, and beryllium, magnesium, calcium, strontium, barium, and sodium. Okay, so let's learn some basic things about the S block element. Okay, so let's start off with the S block element. So here it consists of two groups. It has one is group 1, another is group 2. Okay, first are known as alkali metals, and the group 2 are known as alkali earth metals. Okay, so alkali metals, these are when H2O is reacted, it gives you hydroxide, strongly hydroxide. And in group 2, this gives oxide hydrides. Which gives rise to alkaline release, alkaline nature, found in earth crust. Okay, so these elements are like found G2. Here we have G1 and G2. Okay, so G1 are alkali metals which are strongly hydroxide, and G2 are alkali earth metal because they form oxide hydrides. Okay, next thing is the valenced electron that is formed. Okay, so in G1 it is NS1. Okay, and G2 it is NS2. Okay, so here the oxidation state is +1. +1 as in there will be loss of electron. Here it is +2, so 2 electrons are lost. Okay, so in G1 it is also known as monovalent ions, while G2 are known as divalent ions. Okay, so now examples of it. The first example, The list of examples that are present in monovalent are lithium, sodium, potassium, rubidium, cesium, francium. It will have sodium will be argon 4s2 1. Rubidium will be some 5s1. Cesium will be xenon 6s1. Francium will be barium 7s1. Okay, so group 1 are the monovalent ions, that is there are only loss of 1 electrons in the atom machine, while the group 2 are the divalent, that is there are loss of 2 electrons. For example, it is beryllium, it is magnesium, it is calcium, it is strontium, it is barium, and it is rubidium. Okay, so these are the divalent. Okay, so here it will be helium 2s2, magnesium will be neon 3s2, calcium will be argon 4s2, strontium will be chromium 5s2, barium will be xenon 6s2, rubidium will be 7s2. Okay, so now in last lecture I think you might be well aware of the diagonal relationship. So let's learn about some diagonal relationship. Okay, so let's have a first quick recap of what we have learned till now. Okay, firstly we learned about the groups that are present. So groups we have G1 and G2. Okay, so G1 is alkali metals, G2 is the alkali earth metal. Then we learned about these are also known as monovalent and these are also known as divalent. Why? Because monovalent have +1 and it has +2. Okay, but one important thing should be noted here is the valence electron. Okay, here it is ns2 and here it is ns1. Okay, so now let's learn about the diagonal relationship of s block element. Okay, so lithium, here lithium will show diagonal relationship to magnesium and beryllium will show diagonal relationship to aluminium. Okay, so here we can conclude the diagonal relationships is due to similar ionic sizes or charge to size ratio. This is the most important thing. Here it has said the diagonal relationship is due to ionic size or due to charge to size ratio. Okay, this is the important thing that we should know in the diagonal relationship, like why there is a diagonal relationship and why there is a relation between the both the elements. Okay, now let's come to the next section, that is the physical properties. Okay, So first will be atomic or ionic radius. First we'll talk about group 1. Okay, so here across the period, that is known as horizontally, it is the largest element in particular period. Now talking about the groups, that is vertical, it is down the group, size increases. So here the atomic radius across the period, it is the largest, and group, it as we go down it increases. Now let's talk about the ionization enthalpy, or you can see the ionization energy. So as we know, ionization energy is inversely proportional to the size. Hence we can say that along the period, it is low in a period, and in group, ionization enthalpy decreases. Okay, so here it says that ionization enthalpy is inversely proportional to the size, and for the period it is low in the period, and group is as we go below it decreases. Third is the hydration enthalpy. Okay, so the relation is hydration enthalpy is directly proportional to the charge to size ratio. That means hydration enthalpy is inversely proportional to the size, and it is directly proportional to the charge. That means less size, that is more hydration, and more charge is also equals to more hydration. This is an important relation. Okay, hydration energy is inversely proportional to the size, directly proportional to the charge. Okay, so here we can say that Li plus has more than sodium plus, then more as potassium plus, and it goes on. Okay, so here we can conclude that lithium has maximum hydration which is into LiCl dot 2H2. So it is mostly hydrated in the form of LiCl dot 2H2. Okay. Now let's talk about the group 2 element.